All right, we're back. We're on page 4 of notes 14 of Calc AB, talking about approximating definite integrals. We're finding it's really not that bad. It's a lot of drawing rectangles and adding them up. Sometimes you draw trapezoids and add them up. Sometimes you do the left and the right and take the average, and that's the trapezoids. Sometimes you talk about the midpoint. Midpoint, clearly not my favorite, but don't let that hinder your love for the midpoint approximation. Like, if that's your favorite, good for you. Let's see if we can do this. Scatter plot below gives selected velocities of a woman during a race. I remember when I first wrote these notes, I just wasn't feeling it when I was writing this problem, and I was just like, a woman runs a race. Her speed in some units are shown below, and it's like, all right, I got to go back and fix that. So I did. Scatter plot. All right, velocities during a race, and you can see them. Oh, you're not a pointer. Here we go. Blah 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 blah. Approximate the distance traveled by the woman during the race. Units are in feet per second. Good to know. Feet per second. Also, I don't know how accurate this is. I just made these up. I mean, some of these look like 7 feet per second is it's more than 2 meters per second. So in 60 seconds, you get, that's not that fast. Is that not that? I think that's not that fast. I'm going to say that's not that fast. I should also look up some speeds so I know things like that, but whatever. Seconds on the horizontal, clearly. And then use a trapezoidal sum for your, all right. Trapezoidal sum, I think it's a good idea to draw them. So we don't need to go crazy here, but one trapezoid. You know, it's so annoying. Just go where you should. It's impossible to line these up. I don't really know why. There's something wrong with me. It's not you, iPad, it's me. These are all of our trapezoids. Ugh. This is why I hate lines, man. They just highlight how bad you are at following lines, basically. It's like, trace this. Oh, nightmare. Woo! I nailed one. Look at that. Ooh. That's pretty good. So that one's amazing. So I'm like, now I like doing this. All right, we need to do some trapezoids. So let's first write down our definite integral. So we're going to say it's the integral from 0 to 10. It's our velocity, so v of t dt. Now this is only an approximation. All right. I'm going to write it here and then move it over. So it's going to be 1/2. And then they have different heights. And in general, I would encourage you always just do each individual trapezoid. It's just easier that way. So it's going to be 1/2, 1. And then I'm going to do 2 plus 5 is 7. That's our first trapezoid. 1/2, 2. So 2 because of this. And then 5 plus 6 is 11. Plus 1/2, 1. And then 6 plus 4, 1 and 10. Plus 1/2, 3, because you're going from 4 to 7. And then, so that's your 3. And then 4 plus 7 is 11. I bet I get one of these wrong, or I bet I get a lot of them wrong. I'm saying for the notes. I bet in the notes I make definitely some fatal error. That's 2, and then 7 by 5 is 12. 2 and 12. And then finally, our last trapezoid is 1/2. The base is 1. And then you got, what are you? 5 plus 2 is 7. So this is kind of the work that I would, this is definitely the work that I would show. I'm going to move this over somewhere. I don't really know. Can I fit it? Let's do that. And then the units of this are going to be feet, because feet per second times seconds. So we'll say feet. And then I'm going to punch this into the calculator. I'm not going to bother switching over because it just takes time. So 1/2 times 7 plus, I mean, is there even a reason to do this? Plus 11 plus 5 plus 33 over 2 plus 12 plus 7 over 2. I think that's right. So that gives me 51.5 feet. So this equals 51.5 feet. So that's how far she went in 10 seconds. That doesn't seem very far. I don't know. I don't think that's very far. Whatever. All right, let's see. Use the data in the table to evaluate each approximation, show a quick sketch for each. Probably not going to do that. Takes a while to make it easier. Does it really? What I'm going to do is I'm going to mark up this table like crazy, multiple colors so that it's like at least a little discernible. All right, -4 to 12, midpoint, 2 rectangles. All right, -4 to 12, midpoint. So we're going to start. I always write the integral that I'm approximating. I mean, you want people to like know what you're doing, right? So approximately -4. So we're going only from -4 to 12. So 2 rectangles. So -4 to 12. What am I saying here? The average of -4 and 12. Add them together, you get 8. Divide by 2, you get 4. 4. Okay. So first thing we're going to do, we're going to go from here. How to do. You know what? I'm going to try to highlight the first time. We're going to go from here to here. And then the midpoint is, so -4 plus 4 is 0 divided by 2 is 0. So the height will be this, right? So the first thing that we're going to do is 8. And then the height is 9, right? So you went 8 from -4 to 4, and then the height is 9. Don't get fooled by the fact that in the table, it doesn't look like this is like directly between them. Numerically it is, and that's all that matters. Why is that? Because we skipped 2 in the table. Tricky. All right, and then we got to do a second one. So we're going to go from 4 to 12, which is also a distance of 8. I mean, that's kind of how midpoints work. 8, and then the midpoint of 4 and 12 is 8, and the height there is 8, so that's really annoying because you could like not know what you're doing and still get that. And then that's our approximation. So what is that? That is 72 and 64, or 8 times 17. I don't want to do either of those. 72 plus, I got to write it, 136. 136, blah, that's a little thing. All right, -4 to 11, a right sum with as many rectangles as possible. Delightful. All right, -4 to 11. So start with what you need to write. -4 to 11, this is what we're finding. We're finding an approximation because we're just using rectangles. All right, so I'm probably gonna do the thing where I write it up here and then bring it down. And what should we do? Let's use a different color. All right, so -4 to 11. Okay, so we're going here and we're using a right thing. So it's gonna be 2 times 6 plus, go from here, that's a 2, and then the height is 9. Then we go here, no, then we go here, that's 4, but the height is 7. Then we're gonna go here, so that's 2, and the height is 5, plus here we go 2, and the height is 8, plus 3, and the height is 10. Okay, so let's bring this down, and then we'll, I'll spend 30 seconds talking about whether or not I want to actually sum this up rather than summing it up. All right, should we do it? I got 12 and 18 is 30. 28 and 10 is 38. I've got 30 and 16 is 46. So 76 plus 38 is 100 plus 14 is 114. Do it however you want. I got 114. I think, I don't know, might be right. Okay, trapezoidal sum, as many trapezoids as possible, 0 to 15. All right, start with the integral that you're gonna find or approximate. Always be writing that. If you're not writing that, you're only like, it's like, what are you doing? What are you, like literally, you're just writing a bunch of things that you're adding up. Like, what are you doing? Well, we're approximating this integral. 0 to 15 trapezoidal sum. 0 to 15 trapezoidal sum. I believe we will use red. All right, so 0 to 15. So the first thing we're gonna do is this. So that's 1/2, 4, and then we add 9 and 7 to get 16, plus here, 1/2, that's 2, and we add 7 and 5 to get 12, plus from here to here, that's 1/2, 2. So they all get a 1/2 because of trapezoids. 1/2, 2, and then 5 plus 8 is 13, plus, go here, 1/2, 3. I'm feeling like I'm not going to actually do this one. Except every time I say that, I just do it anyway. Here, 1/2, only 1. And then add those, you get 24. And then here, plus 1/2. 3. Usually when you're doing this, you hope that there's like one even number so that it'll cancel with the 1/2. That's actually later in your life when you get to polar areas, which is like what? But when you get to polar areas, you're always going to hope that that happens. It's like, oh man. I just drop you wherever. Just drop you, you know, wherever. All right, should we do it? I don't know. I mean, I guess we should. Let's see what kind of damage we can do on this. All right, I'm gonna do 32 plus 12 plus 13 plus 27 plus 12. So I'm like looking for the evens so that I can like cancel them. Plus 39. All right, I think that's okay so far potentially. So this is 44 plus 40 plus 51. 84 plus 51, 135. I get 135. None of these answers really like have anything to do with anything else. So like you can't even really get a sense of like, is it like accurate? I don't know. Because all the bounds are different. But anyway, this is like a very, very classic problem where you're asked to do it several different ways. You get a bunch of answers. Key thing, the approximately equal to sign. If you did not use those, go back and fix them and hang your head in shame for at least a little bit. So I hope I did them right. But anyway, pretty good example, I think. And also at the top, don't forget the lady who ran the race. Good for her. So let's put an end to this, and I'll be back and see you in the next one.